Welcome to the resit revision lecture for 2017 Summer Resit Data Networks and the Web. Obviously you should look back at all the slides, try all the labs for your revision, but this is a refresher of some of the key topics, which I hope will be helpful. Now you can see from this map of the content that we covered in the lectures and in the labs that there's a wide range of things that we did and topics that we covered. And in this refresher lecture, the things I will cover in particular are the Internet Protocol Stack, so TCP/IP, and we'll look at also some of the sample questions off this Spring Exam Paper 2016. I'm going to look at cookies, object-oriented PHP, model view controller, PHP data objects, and AJAX and web scraping. Now, you can see from that list that actually in the course, and I'm referring particularly here to Term 2, we did reach a level of sophistication actually with some of those topics in terms of the kind of things we were trying and implementing. But I just wanted to emphasize, don't forget the basics. When doing your revision, go back to the first 1 or 2 lectures and 1 or 2 labs and make sure you understand cookies and sessions and uploading files and the real bread and butter basics, as those will also be important to any test or exam you do in this topic. Those are the basics. Okay, what we're looking at here is a diagram of the structure of communication between a server and a client across the internet. So what you're looking at there on the right hand side, those things labelled with L, they're the layers of the internet protocol, the internet protocol stack. And what I've done is there's those labels there of the internet protocol stack, and also various other labels like X1, X2, X3 and so on that represent different parts of the way the communication happens across the internet. So what you need to do is pause this video at this point and try to work out from your knowledge or by looking at notes what actually those things stand for. What are L1 to L4? What are X1 to X5? Okay, so what you're looking at in particular is, as well as the layers, is for example the numbers X1 and X2. They label the communication between the server B and the client C. Okay, obviously those B and C both have IP addresses. You've got IP address C, IP address B, but there's another pair of numbers, X1 and X2. They seem to go together with the IP addresses to make the complete communication. What are those? What kind of numbers are they? Those numbers X1 and X2, what do they represent? And given that B is a server, what is the process X3? What is the process? In other words, what's the program there? And given what that program is likely to be, what is the number X2 likely to be? You can predict what that number is in most cases. X5 is the line of communication between the client and the server, and that has a particular name. What is that whole communication that's represented by those 4 numbers, the IP addresses in X1, X2? What is that called? And also we've got another IP address there on the bottom left, X4. Okay, that's meant to represent a computer inside a network like the college network or your home computer that has to communicate to the outside world through a router. That router has its own IP address on the outside. What is particular about IP address X4, and what is that called? Okay, so let's have a look at what these labels actually stand for. We've got labels L over there on the right hand side, and they're to do with the Internet Protocol Stack itself. That's what they represent. And now you've got the physical layer at the bottom. That's already labelled, and that's the actual cables. The cables, submarine cables, Ethernet cables, or possibly radio waves in the case of Wi-Fi, and that carries the information in the first place. Can't do anything without the physical layer. But above that you've got the Internet Protocol stack itself. You've got layer 4, that's the link layer. That is things like the Ethernet connections, the stuff, the protocol part that makes it possible to transmit the information from one point to the next. But above that you've got layer 3, which is the Internet layer. That connects these separated sections into the Internet itself. It fires the packets around using IP addresses. And above that is the transport layer, which makes sure those packets get reassembled into something meaningful. And then they get transported, rather supplied upwards if you like, to layer 1, which is the application layer. That's where all the stuff that we care about really happens. So what about these mysterious numbers, X1 and X2? Well, they're actually port numbers. In relation to the IP addresses, it's also the port numbers that define, together with the IP addresses, the unique connection between clients and servers. So between the client here and the server here, we've got an IP address for both and a port number for both. Now that combination of 4 numbers defines a socket. That's what's labelled here as X5. That's the actual unique connection between the client and the server across the internet. Now we don't know usually what the client port number is, nor do we care, but the port number of the server is defined and will usually be something like 80. So we can say, that's why we can say what number X2 is likely to be. It's likely to be 80, possibly 8080 or something along those lines. There's a set of numbers which are defined as usually used for HTTP web services, and so that's on port 80. The other number we were going to identify here is the IP address X4. Now what is that? It's actually one of a class of IP addresses that don't root on the internet. So they are IP addresses, you'll recognize them, but they only work inside a network, inside an organization, inside a room, inside some kind of local area, and they have the form 192.168.04 or possibly 10.0.0.1, 10.0.0.2. There are a few classes of these non-routable IP addresses. The connection between those and the outside world is managed by, let's say, a router which translates between these internal non-routable addresses and its own external routable. It is connected to the internet, its own external routable address. Now what kind of thing is running across these connections, the internet protocol? Well, in our case, between a client and a server, it's pretty typical a web request, and that's what we concentrated on in the course. We were writing programs to handle web requests and return information, and what we're normally handling are either GET or POST requests. A GET request will provide the parameters in the URL as a key value pair, and what that's doing is asking us to dynamically generate, perhaps by pulling stuff from a database. That was what was typical for us, to dynamically generate a page to send back to the client, based on what we know, based on what's stored in the database and so forth. A POST request, on the other hand, is almost certainly a form, and that might be asking the server to change something in that database, or to change something at the server end. So it might be uploading, or it might be editing a blog post or something like that. And that will usually be sent in the body of the request, whereas the GET request, that's in the URL itself. Okay, so let's have a look at what these labels actually stand for. We've got labels L over there on the right hand side, and they're to do with the Internet Protocol stack itself. That's what they represent. And now you've got the physical layer at the bottom. That's already labelled, and that's the actual cables. The cables, submarine cables, Ethernet cables, or possibly radio waves in the case of Wi-Fi, and that carries the information in the first place. Can't do anything without the physical layer. But above that you've got the Internet Protocol stack itself. You've got layer 4, that's the link layer. That is things like the Ethernet connections, the stuff, the protocol part that makes it possible to transmit the information from one point to the next. But above that you've got layer 3, which is the Internet layer. That connects these separated sections into the internet itself. It fires the packets around using IP addresses. And above that is the transport layer, which makes sure those packets get reassembled into something meaningful. And then they get transported, rather supplied upwards, if you like, to layer 1, which is the application layer. That's where all the stuff that we care about really happens. So what about these mysterious numbers, X1 and X2? Well, they're actually port numbers. In relation to the IP addresses, it's also the port numbers that define, together with the IP addresses, the unique connection between clients and servers. So between the client here and the server here, we've got an IP address for both and a port number for both. Now that combination of 4 numbers defines a socket. That's what's labelled here as X5. That's the actual unique connection between the client and the server across the internet. Now, we don't know usually what the client port number is, nor do we care. But the port number of the server is defined and will usually be something like 80. So we can say, that's why we can say what number X2 is likely to be. It's likely to be 80, possibly 8080 or something along those lines. There's a set of numbers which are defined as usually used for HTTP web services, and so that's on port 80. The other number we were going to identify here is the IP address X4. Now what is that? It's actually one of a class of IP addresses that don't root on the internet. So they are IP addresses, you'll recognize them, but they only work inside a network, inside an organization, inside a room, inside some kind of local area, and they have the form 192.168.04 or possibly 10.0.0.1, 10.0.0.2. There are a few classes of these non-routable IP addresses. The connection between those and the outside world is managed by, let's say, a router which translates between these internal non-routable addresses and its own external routable. It is connected to the internet, its own external routable address. Now, what kind of thing is running across these connections, the internet protocol? Well, in our case, between a client and a server, it's pretty typical a web request, and that's what we concentrated on in the course. We were writing programs to handle web requests and return information, and what we're normally handling are either GET or POST requests. A GET request will provide the parameters in the URL as a key value pair, and what that's doing is asking us to dynamically generate, perhaps by pulling stuff from a database. That was what was typical for us, to dynamically generate a page to send back to the client, based on what we know, based on what's stored in the database and so forth. A POST request, on the other hand, is almost certainly a form, and that might be asking the server to change something in that database, or to change something at the server end. So it might be uploading, or it might be editing a blog post or something like that. And that will usually be sent in the body of the request, whereas the GET request, that's in the URL itself. Okay, now that we've gone through that refresher on the Internet Protocol Stack and TCP/IP and all that kind of stuff, we're going to have a look at a few of the questions of the Spring 2016 exam paper. I'm going to have a look at questions 4, 5, 34 and 35. So this will be a good time to pause and try those yourself. Question 4. What is the underlying protocol which defines how data is formatted and transmitted across the World Wide Web? Well, of course, if you remember the kind of exam technique we're talking about, read the question carefully. It doesn't say what's the underlying protocol which defines how data is transmitted across the internet. So that would obviously be the Internet Protocol. This is being, it's asking a different question. What is it? The protocol for the World Wide Web. That's the application layer. It's got its own protocol, like all applications. In this case, it's the HTTP, Hypertext Transfer Protocol. So this question has the answer A. If we look at question 5, we're asking how may data be transmitted to a web server in an HTTP GET request? It could be sent within the HTML form data, it may be sent within the body of the request, it may be sent by appending the request URL with a query string containing field value pairs, or simply it can't, because data can only be retrieved with a GET request. Well, that last one, D, it's there for the unwary. the idea that it's a GET request, which kind of sounds like you're just retrieving stuff, that might fool somebody who's not thinking carefully about the question. But it's an HTTP GET request. We're familiar with two kinds, GET and POST, and the GET request is the one that uses values in the query string. So in the web address, and then a question mark, and then a series of field value pairs. So the answer is C. You're looking for something like a request to www.blog.com/post, or rather question mark post ID equals 21. So you're looking for the post number 21, right? So blog.com question mark post ID equals 1. Now we're going to look at question 34. In the Internet Protocol stack, which protocol layer is primarily responsible for reliable, error-free transmission? So the clue here is really in the name. Is it TCP, IP, HTTP, SSH? We've already talked about HTTP being an application layer protocol, and in fact the answer is question A, because T is transmission control protocol. So it's the transport layer, it's the layer, the IP layer, the internet layer, that the stuff bangs around at the internet layer. The transmission layer makes sure that it arrives safely, it gets reassembled in the right order, and there's no gaps. So it's the transmission control protocol. In an exam you can be pretty sure to get at least 1, 2, 3 questions in the short section about the internet itself, about the protocol stack, and so it's well worth revision. For question 35, SMTP is an email protocol. Which layer of the Internet Protocol stack is it part of? Well, it may be a protocol of its own. It's not part of the stack, it's an application. Email is an application, and the answer here is A. Okay, now we're going to look at cookies. Now, you know that cookies exist really because HTTP, that's the web protocol, is stateless, which means when it was set up, it didn't provide a way for servers to remember clients in between requests. The whole idea was a client made a request, the server served it, and that was gone. And that simplified things a lot and made things a lot more efficient and effective in terms of the servers able to deal with lots and lots of requests and keeping the protocols at either end nicely sort of separated from each other. But of course, as soon as identities are required on the internet, let alone the processes of buying things or logging in or any of the other kind of most useful interactions that we now have with the internet, you need a way to keep state, you need a way to remember who's who between requests, between specific interactions of the client and the server. There has to be some kind of continuity, and the first way to maintain that continuity is with cookies. So here we've got a series of cookie interactions between a client and a server, and what I want you to do is think about what goes in what's happening in those blacked out boxes. There's a client. Let's imagine, for the purpose of, I can't quite remember why this diagram is labelled eBay and Amazon, but anyway, there's a client making a request from a server, let's say it's Amazon website, and the Amazon server has a reason to want to remember that client in between these interactions, over a series of interactions. So what does it do in that first blank box? And then what does that lead to in the second blank box? So here we have the first blank box, and then you have the second blank box. What happens between those in both of those interactions in relation to the idea of a cookie? And then you've got an interaction sometime later, the third blank box. What's happening in that interaction? Okay, now we're going to look at what's happening in those interactions, and it's very straightforward. What's happening when the server first receives the request from the client is that it wishes to set a cookie. So it instructs the client to set the cookie, and that's what we do in the PHP code we were using. We instruct the client via the set cookie command. In PHP doesn't actually have the hyphen shown in the box here. We'll look at the actual command in a moment, but we set the cookie. That cookie is then a piece of information stored by the client, i.e. by the browser, at the user's end. Then that piece of information is passed back in a subsequent request. In that third box, the cookie is passed back, part of the header, to the server. The server recognizes that cookie, takes the appropriate action, personalizes the appropriate content, whatever it is, and so the reactions continue, which means that even a week later, when the cookie is still stored on the client, it recontacts the server for a subsequent interaction, and again the server can take appropriate action based on what that cookie was set as. What I want to do here is just refer you back to the original slides. This is for cookies and sessions, which would be week 11. So we can see here that on the slides we're talking about why do we have cookies. We're talking about what cookies are and what they actually consist of, the processes that they go through. Most importantly, perhaps, how do we set a cookie, what parameters the cookie can have, how we read that cookie once it is set, how the cookies work within the PHP code that we're working with, the specifics of the interaction that we just looked at, which explain why, having written code that sets a cookie, you can't immediately read the value of that cookie until the next page request has been made. These are the specific parameters that work for cookies. So you've got the name, value, the time it lasts for, and then some more specific things like path and domain, perhaps. How they evaporate by themselves because of the elapsed time, or how you can delete them. A little bit more about the storage of cookies, and then moving on to sessions, of course. And sessions are a server-side way of storing information about the user across over the stateless protocol of HTTP, so in other words just remembering stuff. It also uses cookies as a way of keeping track of a particular client, but all the information is stored on the server. And these are the key differences between cookies and sessions. Sessions are stored on the server, as I just said, and they're encrypted, they can include more information, they use hidden fields, whereas cookies are visible in the request, and so on, so forth. So have a look back at the slides, both about cookies and sessions, although sessions you should be familiar with also from the coursework. Okay, now we're going to look at object-oriented programming. We covered this thoroughly in lecture 14 and lab 15. And you remember that there's nothing actually new about this stuff. There's no new control structures, no new intrinsic functions in the language PHP. We're just rearranging stuff in classes to make objects, to make it more modular, more structured, more easy to understand, and it allows us to program with patterns. And we're going to look at one of those patterns in a bit, which is Model View Controller. So this is just the basics of object-oriented programming. We take variables into this class. They become called attributes, and we construct functions in the class, and they become called methods. Now in this example I've put in some blanks. Now the class defined here, called myClass, is used then to generate another class called myOtherClass, somehow related to myClass by, in this case, blank 4. And then below you can see we're executing a series of commands in our PHP program. We're creating a new object, newObj, as a new instance of this myOtherClass. As we create it, we're passing a string, hello world. Then we're calling the getP method of this new object. Then we call the setP method of this new object. We pass a different string, goodbye world. We call again the getP method, and then we call the new method. The output of these activities is at the bottom there, hello world, goodbye world, and back again. what I want you to perhaps in this case pause the video, think about is what are the values of the blank 1, blank 2, blank 3 and blank 4 inside that construction of the classes. It's very straightforward, and these are just the very basics of object-oriented program that you need to know in order to be able to pass any kind of questions in the exam relating to object-oriented programming. So have a look at this for a moment, pause the video, and then I'll show you what those blanks should be. So here is the class is my class and my other class with the blanks filled in. And if we look back, what was the first blank? It was the declaration of that attribute $P1, and here it's public. So what we're saying is that attribute is accessible publicly by anyone who's using the class can see that attribute. The next blank was public function blank v1, and that was public function construct. The constructor in a class is the thing that gets executed right at the first moment that it's created, when it's instantiated. This will be whatever's inside the constructor will be executed, and that sets up stuff for the class. So in this case it gives the attribute P1 the value $V1, whatever's passed to the constructor. So you can see in our case that was the string hello world, and that gets passed to the attribute P1. So then when you use the getP method, that returns the value of P1, which we set up to be hello world. You'll see that from the original one we had blank 3. This blank 3 is new val, well this P1, because we're assigning the attribute P1 to the value that we passed in when we call the setter function set P. That's what we do when we pass goodbye world. We set a new value for P1 by passing a new string, in this case, to become set as the value of P1. And then the final one was down the bottom there, my other class, blank for my class. Well, obviously it extends. This is inheritance. This is another reason why it's useful to do things with classes. You set up a basic set of attributes and methods, and you can then build on top of that by extending the class, and that introduces also a new method called new method, which echoes back again. So you can see how we got the output that we had from that set of commands at the bottom was hello world, goodbye world, and back again. And that shows you the basic construction of classes and the instantiation of objects, how we use attributes and methods in object-oriented PHP. Okay, so we've looked at object-oriented programming, and I said the thing that object-oriented programming makes possible is programming with patterns, kind of architectural structures, if you like. And the pattern that we used during the course, as I'm sure you remember, is model view controller. This diagram, which I hope you also remember, is a diagrammatic representation of how this works. The controller is what's set up to respond to the user. The controller then manipulates the model, so in other words the data structure, the database in concrete terms, and the ensuing changes are reflected by being passed to a view which shows the result of those manipulations and also sets up any future interaction, and that's what the user then sees again. And if they interact with that, they'll be interacting with a controller that then manipulates the model and updates the view, and so on and so on and so on. That's the model view controller pattern. What we have here is a kind of idealized example of the structure in code of an MVC pattern. We've got a model, a view in a class. We construct, well, this has been set up as an exercise, and you could do a good job of refreshing your own understanding by pausing the tape for a minute and having a look at this exercise and trying to remember, of the three answers presented below A, B, C, which allocation of X, Y and Z in the code correctly corresponds to M for model, V for viewer, or C for controller. So what we've got here is we set up something, the X, we set up something else, the Y, to which we pass the new X which we've instantiated, and we also set up a Z which gets past the X that we instantiated, and then we've got a little bit of a control structure which you can see very much like our real code is responding to parameters passed in a GET request. So the superglobal array $_get, that contains the key value pairs that are substituted in any in any URL from a GET request. Those values go into the GET array. So, and it's saying that if there is an action that's non-empty, then you invoke a method on Y, which is the chosen action, and then that's the Z is echoed using the output method of Z. So what are those things? Think about it for a minute. Of course, what we've got here is the instantiation of a model, and the model is passed to a controller. It's the controller that responds to the action, and the results of that action are passed to the view. The view also has access to the model, or the change model in this case, depending on what the action is. And so that's how models, view and controller slot together. So what we've got here is a slightly more realistic set of code for model view controller pattern. The model uses a constructor function to set up our initial piece of data, which is a string actually. That's passed to the controller, and also the controller and the model are both passed to the view. Now this doesn't actually do anything, except if you instantiate these three things and set up a new model, a new controller and a new view, it will be able to successfully output the string, which is not that amazing. What happens if we try to add a bit of interactivity here? You can see that there are two potential statements, one in the controller and one in the view, which are a kind of minimal addition to add the more realistic interactivity into this model, if you like. And they will partner with the PHP script, which you can at least half see on the right, which instantiates a model and a new controller and a view, which has which then has also a control structure which responds to something passed as an action using a GET request. So action there will be something passed in the URL. It's a GET request. Depending on what action is set as, the controller will take an appropriate action. So you're passing a parameter in the URL, that goes to the controller, and the controller does something. That will change something, and that change will be reflected in the view. That's how these things fit together. The controller responds to an action, decides what to do, changes something in the model, and that change is reflected in the view. Again, this is still idealized, but you could think for a second how this would work. What minimal statements do you need in the controller and the view to make this work? And here you can see what I did put in those statements as a way of demonstrating this. In the controller, you've got a response to the action of clicking, and if on the original string, and then if that happens, the string is updated. The model, which is our string is updated to say updated data. And in the view, you can see the view is set up with a new statement so that it outputs the original string as a clickable link. It outputs the original string as a clickable link to allow the user to interact with this mini model view controller structure. So that's a little bit more of a realistic view. Now obviously we covered this in reality through our coursework blog. So to refresh yourselves about model view controller, you should look at the whole of lecture 15. You can look at lab 16, which introduces the practice of model view controller, and also, if I remember correctly, starts the process of setting up the coursework blog, and it's in the coursework blog that we actually implement practically, perhaps slightly more messily than these ideal examples, model view controller pattern. Okay, now we're going to have a look at a bit of a refresher on PDO, PHP Data Objects. Now this is just a different way to connect from our PHP script to the database at the back end, the relational database. We're actually still going to use a MySQL database, but we used a different interface. Since lecture 16 and the work that we did in lab 17, we no longer use the MySQL PHP API. We use the more general PHP Data Objects PDO API. Now this is lecture 16, and we'll have a look at what it is and why we do it. So PDO is a very general API, an abstraction library. It just allows you to write your programs, connect to databases, manipulate databases in a straightforward way, and in an object-oriented way in the case of PDO. So the most fundamental thing that we need to do is establish a connection to the database. So $PDO, which would be the database handle, is new PDO, some credentials, username, password. Now the first part of that, which is officially called the data source name, doesn't really matter. That contains the information about the database itself. In other words, as you can see, that it is a MySQL database, that is locally hosted, it's on localhost, and that its name in this case is the record store. Now we need this database handle, this $PDO, we need that in order to have a connection to the database itself from our PHP program. Without that, we're going nowhere. And as I said, one of the aspects of PDO, or the advantages of PDO, is that it's object-oriented, so we can use try, catch structures, and it fits in with the rest of our object-oriented programming, which is all in a way oriented towards being able to write programs in patterns like MVC. We'll see that in a second. And we'll look at how we did it in the coursework blog. We'll have a look at this carefully. We're establishing that the attributes of a MySQL database on the local host with this certain name. We're giving the username and the password, and then we create a new database handle, $DB. We set some attributes for that, which is really to do with the error reporting, and then we're connected, unless we have to catch an exception when the connection failed. All about setting up the database handle and then passing that, which we'll look at in a second, passing that to the classes, the objects in our program that can actually make use of it, that need it. And then we can use it to run queries. We can either, as it were, retrieve, search for stuff in the database, retrieve things with certain characteristics from the database, or we can update, insert, we can update the contents of the database, insert new content into the database using queries that are methods of the database handle object that we set up. And once you've executed a query, you can extract the results using that PDO statement object. And we tended to use fetch all, which just gets back all of the, for example, all of the rows in the result that you've looked for. So we're trying to get all the records that are blog posts, and then we want to fetch all from this this PDO statement. Now, I just wanted to remind you what this looks like in code if you haven't looked back at it in a while. This is the blog table from our coursework blog, and you can see that it uses PDO. We'll see what happens when we go through. The first thing to notice, and actually a really important thing, is here is the database handle $db. This is being passed from the calling program. It's already been connected. There's already a connection to the database being made using PDO, and we'll see that in a second. And this is being passed in the constructor into the to be able to be used inside the blog table class. And then we've got various methods: save entry, get all entries, get entry. You can see, for example, get all entries. We set up an SQL statement, and then we execute it. We prepare the statement, and then we execute the statement. And these two steps of preparing and then executing are typical characteristic of our PDO way of doing things. And then you return the results are then, as it were, contained within the statement object itself, right? So you pass back the statement object, and then get hold of the results. We'll see a little bit more about this prepare and execute pattern if we look at the save entry method. In this case, we're actually passing some we're not just invoking an SQL statement, we're passing some parameters, the title and entry of a new blog post. So we have the SQL again, and in this case, key point, we have these question mark placeholders. That's that statement gets prepared, and then we have as an array the two pieces of data, the title and the entry, that we're going to pass to this query so that it can save this blog entry into the database. So that's the form data is the array containing the parameters of the SQL statement, if you like, and then we execute the statement passing the parameters. That's the key thing about PDO. It separates the SQL statement from the values that are being passed in from the program or from a form or whatever else it is, and then executes that as a statement. And we can see, if we look at the index, where the database handler is coming from. Way up in the calling program, it instantiates this database connection db equals new PDO, the information about the database, the username and password, that information we've set in a configuration file. There it is. That's the database handle. That gets passed into the blog table via the constructor, and then can then be used as a way of connecting to the database and executing these various queries. So now I want to look, at least briefly, at a bit of revising Ajax. Ajax is asynchronous JavaScript and XML. And it's really, again, nothing new, in the sense that all Ajax is doing is making HTTP requests, the same as a browser always makes off a server. But the difference with Ajax requests is they can be made without reloading the page. So they're implemented by JavaScript, which has the ability to make HTTP requests independently of a page load. The difference between that is represented in these two diagrams. The old way of doing things is when filling In this case, it looks like they're thinking about a groceries cart. You know, you add an item, you post it, it comes back with that item added. You add something else, you post it, comes back with that item added, and so on and so forth. With Ajax, it's making the requests behind the scenes and updating the web page in real time, smoothly and seamlessly, and so on. And again, you can see the difference here represented with the top half of that diagram in the dotted lines. Your normal HTTP requests. The bottom half is the Ajax, let's say, engine through the function XML HTTP request, making calls on behalf of the browser to the server and handling what comes back, and using that to update the document object model of the page so that it can update interactively. Now, just to look at the code that implements an Ajax request, we've got a demonstration page which has a script, JavaScript code here, which includes the fact that when the button is clicked, it will invoke a function called makeRequest, and it passes the value ajax2.php to that makeRequest script. And if we look what the makeRequest script itself does, the main aspect of it here is that it instantiates a new XML HTTP request. That's the Ajax function that will actually make the calls to the server, and it provides here for the URL that will be called. That's what gets passed to the function when it's, as we saw, ajax2.php is the URL will be called, and it'll be called as a GET request. But also this makeRequest function provides for how to respond, and how to respond, the onReady state change, is by invoking another function that's called alert contents. And alert contents checks that everything is okay with the response, that the HTTP request has been done, that the status is the HTTP response, because of course it has a response code. It's an HTTP request, so it has a response. It could be 404 if it's not found, or some other error. It checks that the HTTP request is status 200, which means everything is good, and all being well, it modifies an element of the page to replace it with whatever comes back as a result of the HTTP request. And this makes sense if we have a look at the script that's being called. All this script does is return back the string gotcha, and that is what would then be inserted into the page as a result of clicking on the button. Click on the button, an Ajax request is made to a certain URL. The request to that URL returns gotcha as a string. The response function understands that the request has gone fine, uses that string that comes back as a response to modify the page. And to the user, it looks like clicking on that button makes that element of the page change without having to reload the entire page. Okay, now we're going to revise a bit around web scraping, which was something that we covered in lecture 17, and we did the practical work in lab 19. So web scraping is basically grabbing the source code of a web page and being able to extract the particular pieces of data, the particular pieces of information that you want from it. And the way we did it, it's basically 3 moves. The first is using curl, which actually grabs the source code of the page or pages that you're pointing at. The second thing is the DOM document object. By essentially dumping your raw page code inside the DOM document, that will interpret it as a document object model, which is obviously what it came from. It's from a web page, and you can recover the structure of that document, which means that you can then navigate through it according to the tags that were in the page and their the way they're hierarchically structured. But we also did a third thing, which was taking that and using that as it were the raw material for XPath, which just gives you a very laser-like search syntax to find exactly what you want out of the web page itself. So we're going to look at those three stages. I'm going to just briefly talk about them, and then we're going to look at how they appear in code. So the first part is curl. Not much to say really. It goes and grabs the source code of a web page, which you're all familiar with. The second part takes that raw source code and interprets it according to the document object model, which then gives you this neat structure that you can navigate. And you can then search, as we'll see when we look at the code in a second, to particular parts of this document object model by following the tree, essentially. The third stage, which is XPath, allows you to construct this very simple yet powerful search syntax of finding the title element, for example. Okay, that's basically navigating through a tree, but finding, in this case, the double slash meaning find all of the div tags under the root of the document, and then the paragraph tags within that, or even more precisely, find all the divs, and then within that find all the divs that have the class of second, or extract from all links within divs the text element, or extract from all links within divs the actual URL that it's linking to. Okay, now we're just going to have a look at the code that implements the scraping activity we just went through. This is the first part, the first of the three, looking at curl itself. And a curl session just extracts from a URL the source code of the web page. To make this actually work, it's about executing a GET request to the URL. You initiate this curl session, then set up a couple of options. One is to tell curl to give you this stuff back as a string. That's what we want, because we want to pass that to the DOM document. So we want to get this source code back as a string, and then we tell it which URL to fetch, and then we tell it to go and fetch it and return the results. And that's pretty much all there is to it. Now, having got that raw source code, as we were saying, we then pass it to the DOM document. So here is a script that combines both of those things. We use curl to grab a web page, and then we create a new DOM document to hold, as it says, hold this as a structure, as a web page structure. It interprets that raw page source as the structure it would have originally have as a DOM document object model, and you take the raw stuff we've scraped, load it into the DOM document, and then that immediately allows us to search. We don't have to have XPath. XPath is an addition, an upgrade, if you like, of the search powers. But because we've now taken that raw source code and arranged it into this hierarchical tree structure, we can then search through for each of the get elements by tag name A, so that in case this is a links we're looking at, anchors as they I think they're originally known in HTML, but anyway, the link element, we can get all the links with that tag, and in this case build an array of the results. So those two operations together actually allow us to do the substance of what we want to do, which is to grab the source code of a web page and be able to extract meaningful information from it. The refinement of adding XPath is simply to give us a powerful yet in some cases sort of simple to remember search syntax that gives us additional selectors and additional sort of search and wildcard syntax to find exactly the piece of information that we want from the page structure. So here's the example that goes through the 3 steps of using curl up here to grab the page, putting the results into the DOM document, and then taking that and passing it to XPath. So we can then use XPath style search here. For example, in this page, which was scraping the staff page off the Department of Computing website, it's looking for some specific parts of that structure. The staff name, which comes inside the H3 elements that have this class teaser title. The silly name for the class is because of that comes directly from the content management system that's being used. And similarly with the email address, we're then looking for these divs with this particular class, and we're looking for the second part of the link element, because that's the way the page is structured. In that is to be found the email address for the staff member. So you've got all those 3 things going on there. Grab the page with curl, structure it with DOM document, and make it searchable with XPath. Well, that's it for this revision lecture, and I just wanted to leave you with a couple of basic exam tips. Probably the most important of which is to get a good night's sleep before the exam. Don't be late, because there's nothing as off-putting as having to sort of rush into an exam in a hurry or just after it's started. In the exam, really do read the questions carefully. You've got plenty of time, so read it carefully, make sure you understand exactly what it is asking, because it may not be exactly what you first assume. And leave time to check your answers. As I say, there's plenty of time in the exam, so I'm sure you can do that. So make sure that you do check your answers, because it's very easy to make a simple slip, and then once you go back with a fresh view on it, you can correct that. And the last thing that myself and Sorrel always say to you is, don't be in a hurry to leave the exam, even if you feel it hasn't gone particularly well. Do stick it out, review what you've done, look for any possibilities of adding stuff, even if you're not sure about it. You don't lose marks for putting down things that in the end don't turn out to be right. But if you have put something down, it does give us a chance to give credit where there is some possibility of credit. We can't, no examiner can give marks where there just is a blank on the paper. Okay, so we're looking to recognise where there's any value in what's been put down on the exam paper. We will recognise anything that has genuine substance, and every mark helps. So give it your best shot, and good luck.